All right, welcome back, everybody. It is noon Eastern. We are going to go ahead and get started with our next reverse pitch. This reverse pitch is going to be on cybersecurity and data management. It will be a panel style, so we look forward to having some great discussion. Feel free to use the chat and Q&A feature to post any questions or ideas or comments that you have throughout this session. Those will be monitored, and if we have time, we will try and get to those at the very end. All right, I'm going to pass it over to EPRI's Jeremy Lawrence to kick us off. Thank you, guys.
Hey, thank you, Hannah. So I'm really excited today to lead the reverse pitch session for cybersecurity and data management. We've got a really good group of panelists today. First, I wanted to start just introducing the panelists. First up, we have Giovanna Helms from Lawrence Livermore National Laboratory. Giovanna is the Associate Program Leader for Civilian Cybersecurity within the Cyber and Infrastructure Resilience Program area at Lawrence Livermore National Laboratory. Giovanna is leading the development and execution of a portfolio of work focused on enhancing the security and resiliency of the nation's critical infrastructure and networks to cyber threats. She was previously a Deputy Associate Program Leader for the Civilian Cybersecurity Program at Lawrence Livermore. Welcome, Giovanna.
Thank you. It's great to be here today.
Next up, we have Wesley Jones. Dr. Wesley Jones is a Principal Technical Scientist and lead in the Complex System Simulation and Optimization Group at NREL. He's currently focused on scalable accelerated computing, stochastic optimization, and artificial intelligence. Welcome, Wesley.
Thanks for having me.
And then last but certainly not least, we have Saida Humaira from the Electric Power Research Institute. Saida is the leader of data governance at EPRI. She has over 20 years of experience in the data management and data governance areas. Her focus areas include extensive data warehousing, master data management, business intelligence, and data governance. She is a cross-functional collaborator with multi-industry experience and expertise in both business and information technology. She's also a champion for using data integrity through defect prevention and data governance as a part of a global business strategy to drive operational efficiency, positive outcomes, and profitability. Welcome, Saida. Thanks for joining us.
Thank you, Jeremy. Thanks for having me here.
So we're really excited to lead this and have this panel discussion with everybody today. Really getting into this, one of the main challenges we had was really limiting and focusing in on just three main themes for today. But we did choose three themes that we thought really presented challenges to both cybersecurity and data management that affect the energy industry. So the first area that we're going to touch on is artificial intelligence for cybersecurity event detection and mitigation. We're also going to talk a little bit about some of the challenges associated with the sophisticated attacks that we typically see that affect the energy industry, but then also supply chain challenges as well. Theme 2, we're going to be looking at how we can potentially address challenges associated with asset management, visibility and change management in industrial control systems and operational technology environments. Really looking at that from the perspective of using or enhancing asset management and configuration management, our OT and ICS environments, to help really serve as the foundation for some of the other tasks that we typically perform from a cybersecurity perspective. And then finally, the last theme, we'll kick it over to Saida to talk a little bit about data management and some of the challenges associated with that. So our first topic we have today is really looking at artificial intelligence for detection and mitigation. So Wesley, I know this is an area that's near and dear to your heart. Could you start us off and talk a little bit about some of the challenges associated with detecting malware in an OT environment?
Yeah, thank you, Jeremy. I would just say that whether dispersed at the transmission or at the distribution level, and at the smart grid and other distributed energy resources that support clean, efficient, reliable, and economic power systems, they introduce challenges and opportunities. We're focused on, as the number of devices and the networks rises in each remains important to secure the but has diminishing visibility in a complex system in which it participates. At NREL, we have an interest in the inherently secure by design future grid controls, and we focus on the challenges around that exponential growth in the devices, the complexity in the ownership, and the trusted supply chain issues. Some of the challenges include the source identification of events with extended and complex communication. Also, there's the autonomous detection and mitigation of zero-day events and operations in rarely experienced circumstances, especially for artificial intelligence, where we haven't had those data sets to necessarily look at. The supply chain security for systems and the complex ownership models, so that things like firmware and patching and identity management can be done well. The improvement of identified events without increasing false positives. There are a number of research activities that we do where we work with utilities on cybersecurity, and these include our emulation platform, our distributed energy resource cybersecurity resilience framework, and our distributed energy resource security framework to help with the evaluation of systems. Also, we've noticed in the very recent past, there's now an executive order for the federal government to improve its efforts to identify, deter, and detect, and respond to these actions. And we're really interested in those things, especially at the device level, where where we'll be able to detect those. In that order, there's, again, interest in enhancing the software supply chain and developing a standardized playbook. There's also quite a bit of emphasis on a zero trust architecture to help, which will be of particular use when we're talking about working with millions of devices. In addition, the Government Accountability Office has released an order that will focus on the U.S. distribution systems, and there again, many devices where we need to work on detecting events at the device level and how those can be aggregated for action and mitigation. I guess that's all I have to start, Jeremy.
Thank you, Wesley. So Wesley, you mentioned, one of the things you mentioned was zero trust. Could you talk about maybe just a little bit about what zero trust is, and maybe some ideas about how machine learning might help enhance zero trust?
Yeah, I think that the idea with zero trust, and it's, I know that it's been working for quite a long time over the last decade in developing architectures. And last August, NIST released their, I forget the specific order, or they released a document which outlines that zero trust architecture. And the principal idea of the zero trust architecture is to move from relying on defenses at perimeters to an environment where nothing is trusted, where it's device and user level authentication to enable many devices or many services and workflows to operate without relying on that perimeter. Of course, with devices on the edge, this is of particular interest, and when we're on the edge, we need to rely on somehow there are those things that could be detected on the edge of the grid or communication network and mitigated there, as well as using artificial intelligence on increased monitoring activities where you're monitoring all of those devices that are living on the edge but aren't necessarily contained within your network.
Yeah, thank you. Yeah, and I think one of the other things that I think is important is just from an overall detection standpoint is being able to help reduce some of the false positives that we typically see. So I think that's an important area as well on how artificial intelligence might help us better detect cybersecurity attacks, but also sift through those false positives, because I think there's some benefits from a response perspective to be able to really hone in on what truly is an attack and what's a false positive as well. So could you talk, Wesley, just a little bit about some other ideas associated with utilizing the artificial intelligence potentially in an OT environment for detection capabilities?
Yeah, I think that there's a particular opportunities with respect to the grid and OT technology. Because as we operate the grid, not only do we have our measurements and information associated with the IT network, we also are tracking things even at the device level with respect to voltages and currents and even frequency that an artificial intelligence system could be aware of. I think sometimes that might be thought of as physics-informed artificial intelligence, where you're using those kinds of physics-informed elements to identify events that are unrealistic physically, or are asking your equipment to go out of bounds with respect to what they're doing. And of course, there's the device level mitigation of those OT cognizant algorithms, so that you don't put your systems into places where it's either could reduce the reliability in the long run, turning things on and off too often, to kind of immediately making sure that things don't overheat or cause other kinds of problems. And of course, those kinds of things can be fed up through the chain to be creating a system-wide perspective and identifying those things which aren't physically or relevant or physically appropriate at the system level. One of the previous speakers earlier today mentioned using artificial intelligence and looking to see differences between the voltage expectations and the load expectations. And those were potential energy theft pieces, which, are related both to the physical but also the cyber security arena.
And Jeremy, if I can chime in here. So I think there's a lot of opportunity to use some of the more advanced machine learning techniques to detect previously unknown compromises. So I think one of the really bigger challenges in this area is being able to detect things that we have not seen before, that we don't know are malicious because we have a signature for it. And so looking at things like we have a project at Lawrence Livermore that's looking at using deep reinforcement learning to understand what the healthy system looks like, both from the network perspective as well as the physics perspective, as Wesley was just talking about. And then look at anything that would actually disrupt that system and either have it perform out of bounds or have some abnormal network behavior, and then alert the operators, obviously, but also potentially even do some corrective actions that would either isolate the threat or potentially mitigate the effects of the attack. And so I think that there's a lot of opportunity there, and really being able to use modeling and high fidelity modeling and simulation to actually build the models of those systems so that we can train these algorithms to understand what a normal baseline healthy behavior of the system looks like. I do want to say, I think there's a lot of really good existing like technologies that industry is bringing from the perspective of we have known signatures, or we have known like TTPs for malicious behavior. So companies like Dragos have really good sensors that can tell you, this is what we're seeing in your system. But from my perspective, the gap is really how do we detect previously unknown malicious activity, or previously unknown zero-day vulnerabilities that are being exploited.
Yeah, thank you, Ivana. That's a great point. And I think, really from a detection point of view, I think that, well, detection and being able to enhance our detection capability is really foundational for an effective response. And so as we look to really, like you mentioned, Ivana, really try to get past being able to detect known signature-based or use signature-based detection for known malware, and looking more past even things like heuristics and looking at understanding what's known baseline normal traffic, and being able to help develop these models so that we can first maybe potentially supplement or augment a signature-based detection capability. But I think the other thing is we look at potentially reducing the number of false positives. I think what we could potentially do from an artificial intelligence and machine learning perspective is really help to get a higher confidence level in those alerts that we get. And I think there's a lot of benefits from that, especially from an orchestration perspective, as we look towards more automated types of responses. I think that can be extremely beneficial because as we do that, I'm always concerned about an automated response for a potential false positive. There's the concept of having the cure being worse than the actual attack itself. And that's where I think we have this potential to build out some additional capability from an artificial intelligence perspective to give us a higher confidence level in those different alerts that we see.
Yeah, exactly. And I think that's something that we have been thinking about a lot. Obviously, the community that we work with is very conservative, and rightfully so. So the way that we're thinking about this is, as we deploy these algorithms in actual environments, we want them to just kind of alert the operator, but they continue to learn the longer that they're deployed in actual environments. And so ultimately, we want to be able to be at a point where our algorithms can tell us, something is happening to the grid, and they can tell us, well, it's the squirrel or it's the Russians, right? So being able to kind of distinguish what is even causing the disturbance in the grid, and then as the confidence in these algorithms grows over time, then moving more towards some maybe conservative actions that would automatically respond to these undesired behaviors.
Yeah, absolutely. Yeah, thank you. Yeah, and I think just one last thing to talk about a little bit here. I know, Wesley, you're really interested in resilient operations of the distributed systems and some of the challenges associated with that. Could you talk a little bit about that and some of the research that you've done?
Yeah, with distributed systems, we've actually been looking at, from an artificial intelligence perspective, how can you operate distribution systems under different kinds of power disruptions where you have assets on the distributed power system to control and support. We're going to have a paper at the PESGM about this, where we use reinforcement learning to learn how to operate a set of renewable energy assets, batteries and solar power to act and operate the power system both from a short-term perspective, balancing voltages and current, as well as a longer term perspective with respect to energy adequacy and not using up our fuel and battery power storage over a limited period of time. In that case, if where the power system might be disrupted, we might have these limited resources where we could learn how to operate the system in a cost-effective way, bringing critical power loads like hospitals and other things online, and before other pieces are brought online. And that's called a prioritized load. And that's the kind of resiliency that we're looking at using artificial intelligence to enable in the future.
Okay, yeah, thank you. Thank you. So I know, Giovanna, you mentioned some of the difficulties detecting zero-day or previously unknown vulnerabilities. And one of the things that I know we've seen recently is just kind of a rise in sophisticated attacks against the energy industry. And I think notably the supply chain is something that we're all really interested in now. Could you talk a little bit about some of the challenges with securing the supply chain and some potential for artificial intelligence to help solve that?
Yeah, definitely. So I think there's just, when we think about different adversary types, we have to like consider our strategy has to consider what type of adversary we're dealing with. And, you know, obviously as a national lab, we're not really concerned with script kiddies or even organized crime groups. We're really looking, how do we protect ourselves from nation state type adversaries? And in those situations, we really have to assume that they're going to be able to compromise us and that they're sufficiently motivated and capable to get into our systems. And so from our perspective, the way that we can kind of deal with that is twofold. One, we have to make sure that you know, we make their job as hard as possible and make it more difficult for them to attack. And the other piece of it is, how do we operate through compromise? So you mentioned supply chain, and that is something that is really a very attractive and effective way for adversaries to exploit, specifically from the firmware perspective, because they can just reach so many devices with one compromised firmware download. And so the first step there is to really understand what's in our systems and how can we, you know, have an inventory, not just of the devices, but of the libraries and functions that are actually in the firmware of our devices. So there's been a lot of attention focused on the software bill of materials and how do we identify what's in our system. Because right now, some of the challenges that we're dealing with, there's a compromise and we don't even know if it's in our system or not. For example, Ripple 20 vulnerability was maybe 3 levels deep in the supply chain of firmware. And so the other challenge here is, how do you do this at scale? So we have hundreds of millions of devices that are deployed, and it's just not really scalable to do that using reverse manual engineering to analyze all this firmware and all the upcoming updates. So what we have been focusing at Lawrence Livermore is using automated capabilities to analyze firmware and automatically generate things like software bill of materials, and being able to look at the behavior of the firmware using automated tools, look for specific things that could be exploited in the firmware, and any kind of inefficiencies, again, in the software that could potentially be vulnerabilities as well. Where I think the artificial intelligence can help here. Well, one, this is like a huge data set, right? So there's a lot of stuff that we can infer from that data if we have it. But the other piece where artificial intelligence and machine learning can help is one of the biggest challenges is actually extracting this firmware from the package that it comes in. And basically some of the work that we're doing right now is figuring out the features that could help us use machine learning to extract that firmware automatically. Part of the challenge is that every single vendor has different ways of doing it, and even two devices from the same vendor, you will not be able to extract the firmware in the same ways and using same unpackers. And so being able to develop these features that we can look for and kind of automatically search through the whole package of the code that we get to understand which are the pieces that need to be analyzed is really going to allow for scalability and our ability to really analyze, all these devices and the firmware that that's on them.
Okay, yeah, thank you. Yeah, and I think that is important. I think you hit on a couple things that I think there really is a good opportunity for us to improve, especially with automating the process for software bill of material development. One of the things I've also seen is just, and you hit on it a little bit, is really the reliance on third-party software packages as well, and the reuse of code. And so a lot of times, utilities won't even know what's installed or what some of those dependencies are. So even just identifying what vulnerabilities affect their systems, it can really be a challenge. And in many cases, it almost becomes a little mini project that's very time intensive, labor intensive. And when you're doing this at the scale, like you mentioned, across hundreds of different facilities, or thousands of different facilities with all kinds of variances and make and model information, specific variances in firmware, build information, it can be quite a challenge. So yeah, it's a very interesting. I agree. I think that's an area where artificial intelligence can certainly help potentially.
Yeah, and I just apologize. I did not define software bill of materials. I don't know if that's needed, but it's basically like a nutrition label for software. So it tells you what's all in your software. So which third-party libraries, what other packages the software is relying on.
Yeah, thank you. Yeah, absolutely. So I know, Wesley, another area that kind of goes along with this that you've been interested in and focused on is supply chain security for systems and just some of the different and complex ownership models. Could you talk a little bit about that and the different ownership models and who has a different hand in the overall supply chain security?
Yeah, I think this just builds upon the complexity that Johanna mentioned, right? Where, when you have companies with large numbers of assets, and they have processes and may have built models to help identify those threats and to help mitigate those threats, all of those issues in the supply chain are have an additional level of complexity when we have complex ownership models. That is, individuals own their own solar modules. They'll own their own home management systems. They operate their own EV charging, and all of these assets, whether they're owned by an individual or by a small group or by a co-op or by different aggregators that are participating in the electricity market, they will all have to have the right cybersecurity posture to help ensure the resilient and reliable operation of the grid. And so I think this goes a little bit down the regime of one of the things in the executive order is focused a little bit on transparency, where we not only will we have to have the ability for very large institutions to manage their cybersecurity risk, but they'll also need to have some transparency to enable, transparency and collaboration with private industry to enable all of these different owners of assets that are participating in a smart grid to have the right level of security.
Okay, yeah, thank you. Yeah, so that was, thank you both, Wesley and Giovanna, for talking through our first theme, really looking at some of the challenges associated with detecting complex malware, mature attacks in the operational technology, the OT environment, the ICS environment, and just some of the potential that we think that artificial intelligence and machine learning has in that space. Our next topic we have is asset and configuration management. I know I heard it was mentioned during the keynote this morning, and I know there was some discussion earlier in some of the other reverse pitches just around asset and configuration management. I think asset and configuration management is really crucial from a cybersecurity perspective, and really quite simply, it's extremely difficult to protect, detect, and respond and recover when you don't know what you have. And so we talked a lot about some of the challenges with vulnerability and patch management, relying on what you have from an installed software, hardware, and like Giovanna mentioned, even some of the third-party code repositories perspective. I think we also see it is even more of a challenge in OT environments because some of the differences between OT and IT environments. So, when we think about it, we have certain components that are definitely interconnected, SCADA, DCS systems, but we have a lot of isolated networks as well that just aren't interconnected to that same level as what we would typically see on an IT in an IT network environment. And so, we have things like skid-mounted controllers, skid-mounted, we have relays and other things that aren't always connected to the same level as what we see on the distributed control system. But they are still susceptible to either physical or portable media types of cyber attacks. And at the end of the day, that device is there for a reason, right? So it can still affect reliable operations. So from an importance perspective, it's still important to know what's there and then also develop a cybersecurity strategy around it. And one of the things that we've seen is that, and many, especially in the generation space, know as active scanning always comes with a little bit of risk on your OT networks. There's a potential that it could create downtime. But also we know that a lot of these OT devices aren't capable of having an agent-based solution or an agent installed. So there has, like Giovanna mentioned, there are some commercially available tools that start to help solve this, but there is, I think, still a challenge in the overall asset and configuration management space. And one of the things that we've seen at EPRI is that, at least in generation space, is many of the electric utilities rely on a manual lockdown process, and that can be, as you can imagine, really challenging because of just how labor intensive it is, but also accuracy can be a difficulty as well, just what information you have available on that asset. And I think the other thing is, as we look over the course of the lifetime of an asset, there's continuous changes to both configuration, but also the installed software and firmware for that asset. And so, I always say that that inventory, if you do a manual inventory, it's good for one day without a good change management process. So that's where some of these tools, like Giovanna mentioned, to really dig down into what's installed first when it arrives from the factory, but also looking at potential solutions for artificial intelligence for asset configuration management and change management throughout that asset's life cycle is, in my opinion, extremely important, and really it's foundational to a lot of the other tasks that we do from a cybersecurity perspective. I know, Giovanna, you had some other ideas as well about potential solutions for artificial intelligence that might be able to help asset and configuration management and that overall life cycle of those components. Could you talk a little bit about that?
Yeah, absolutely. So I think, and I completely agree with you, I think there's not really an effective solution yet for understanding and characterizing the OT environment. The even commercial tools that exist for passively scanning the network will not really be able to recognize the more obscure and proprietary operating systems that are running on OT networks or the services that are running. So, they will be able to identify that there's something on this IP address, but they will not be able to tell you much more about it. Traditionally, the scanning tools that are used for IT networks are based on fingerprinting. So you're basically manually building a database of the fingerprints of all the devices that you can find, and then your scanner would recognize and match to that fingerprint. Again, with the diversity of devices and vendors and operating systems that we have in OT environment, those solutions are just not as effective, or that approach is not as effective. And so one thing that we have been working on at Lawrence Livermore with our lab-directed research and development funding, which is our internal funding in the lab, is to use machine learning to characterize OT devices and the whole environment. And so we're basically using features at the network and protocol level to infer the device vendor, device model, and we're hoping in the future that we will even be able to infer the actual firmware that's running on the device. And so that is a really powerful capability just from the kind of, if you think about the NIST framework, just from the identify point of view. So obviously, as you said, Jeremy, we have to know what's in our system in order to defend it. We cannot protect something that we don't know is there. And so being able to characterize the environment and understand what devices are there, how they're configured, and how they're interacting with each other. Are they, always, these two devices are always talking to each other, and that's normal. But then we can take it like to the next level and use these same features to identify anomalies in the behavior of the system. So looking at configurations of different devices, if we have 7, exact same devices, and 6 of them are configured exactly the same, and the 7th is configured slightly different, that could be a misconfiguration. It could be intentional because that device is operating, in a different environment, or it could be something malicious that was intentionally, misconfigured by an adversary. And so those are the types of things that we can do in this kind of environment and use machine learning to really be able to understand what our systems look like and how do they behave, and whether that is normal or not. I do want to touch, I think there's on a kind of connecting the previous supply chain theme with this. So the kind of vision that we have at Lawrence Livermore is being able to have the device characterization, and so we're able to understand what's in our devices, and we know the vendors, we know the device models, and we know as I said, we're working on the firmware version, not promising that, but ideally, let's say we have that. And then on the other hand, we have our software bill of material. And so we have a library and a database of what's in the firmware, what are the third-party libraries, what are the functions. So imagine a new vulnerability comes out and we're able to put those two data sets together. That would significantly increase our ability for a targeted response, and being able to say, okay, we have a vulnerable library, it's affecting these firmware versions in these devices, and we actually know that they're in all these different environments, and we can notify those people, we can tell them that they're compromised, and we can tell them how to protect themselves against it. And so I think all this data coming together is, a really powerful thing that, I'm hoping we're going to have in the future. And just to add another note, the most recent, the action plan that Biden administration just put out is really calling for more visibility into our OT systems. And so being able to kind of understand what's on those networks is really essential part of that 100-day action plan.
Yeah, absolutely. And you hit on a couple of things. I always think of, one of the challenges from an asset and configuration management perspective is, I look at it from two different perspectives. One is increasing the granularity of information. So we want to have granular enough information that we can use it to identify some of the things like you talked about, where an adversary may misconfigure a device, being able to understand those types of things. Understanding the third-party software dependencies and those types of things as well. But then accuracy, so granularity and accuracy, and having really a truly accurate list. It's kind of the holy grail. I've heard utility members call it the holy grail for asset management. So I think that is a challenge, is coming up with a solution for both of those two, and definitely an area that artificial intelligence has some potential benefits. I will just mention, feel free to drop questions in the chat box in the Q&A. We do have one question, and the question is, do we use honeypots for detection? So I'll say honeypots can definitely be part of the solution. I've seen them be used in IT environments and other environments as well. And just to understand what that means is, so for people that aren't familiar with cybersecurity, a honeypot is essentially something that is meant to sit out there and look desirable from an attacker's perspective, and also look like it's partly vulnerable as well. And then the idea is that as an attacker goes after that honeypot, we have alerts and alarming capabilities associated with that honeypot as well. So that is something that can be used, and it's just part of the overall, I think, defense in depth strategy that I have seen used. So thank you, and again, feel free to drop any questions in the chat box, and we'll get to those at the end. So I think this is a good time then to transition over to theme 3, which is looking at data management and protection of sensitive information. I know, Saida, this is really your main focus area. Real quick, before we even get into some of the challenges, would you be able to talk a little bit about just some of the privacy best practices that you've seen?
Yeah, sure. Hi, everyone. As we all know, like data is the backbone for all of our programs, especially when it comes to AI and other stuff. So data is so much important. We all know the term GIGO, garbage in, garbage out. In order to assure that we don't fall into that, we definitely have to um, follow some data governance in our program. But before, Jeremy, let me address the data privacy questions first, and then we will go into the challenges and opportunities of what data governance has to offer. So for data privacy, like we all have some sensitive information, different kinds of data classified in our organization. So we need to kind of build establish a ethos of compliance, so that we build the confidence in our data at our organization. So for I'm listing some of the best practices for data privacy. And other thing is to leverage a risk-based approach to prioritize our security and privacy requirements. And also, like I had mentioned, data classification. We need to classify the data into several different categories. And like Joanna had mentioned, that unless you don't know what you don't know, if you don't know your data, you don't know what you have to protect out there. So we have to first have a data repository, a metadata in place. So strengthening metadata management in our data lineage capabilities is something which we have to build on, so that we know what data we have to manage from a sensitive data protection and a data privacy perspective. So, and then the other thing is also implementing the workflows. So once we know who the data owners are, establish the data stewardship, we will also be able to establish some controls, so that we have some workflows which we have to follow in case of some restricted data or confidential data. And one other thing is, the more you educate, the more you communicate on your internal privacy policies, the better it is. I usually believe the more it is well understood, accessible, and it should be effective for the data privacy to be kind of implemented. So overall, I think metadata management and having the data classified, and also having some kind of a data lineage established, would be some of the best practices that we would want to implement the data privacy. So that is the response to your question, Jeremy. So we can go back and see what the data governance is all about. So when you know that data is an asset, data is an asset for sure, and we need to govern the asset. So data governance is the solution for all of this. So data governance, when you Google it out there, you will see that there are a lot of different definitions and all. But to be simple, what data governance is, it's all about putting a framework in place of all the roles and responsibilities of the policies and procedures. So today, as more privacy and protection regulations, they continue to emerge, especially the GDPR, data leaders, they should work closely with compliance and legal teams. So in order to implement the data privacy. And data governance is very critical in managing your sensitive data in a more realistic and a proactive manner versus a reactive manner. So while we all agree that data security and privacy should be implemented to reduce risk, but it should not be at the cost of availability and usability. So it's a balance. Like you have to enforce some of the privacy policies, but on the other hand, you have to also make sure that the stakeholders have the data available and usable. So let's talk about a little bit on the risk of lack of a data governance framework. What happens if there is no data governance framework? So definitely there will not be any trust in your data. The stakeholders, the lack of trust in data is a huge thing there, and you will not know what data is out there, so you can protect it. And then your reputation is at stake, and there will be, with all of the policies and the legal compliances and privacy acts, there will be heavy penalties for the companies. So that is one other. The other one is we don't have a single version of truth if we don't have a data governance in place. So there is no way you can go with the data driven decisions. So those are some of the risks. We all are aware of that. So let's talk about what it takes to kind of what are the main challenges when we get to the point that we are ready to implement the data governance. Being coming from a background working on different industries, implementing the data governance at a different maturity levels for each of these companies, I have just listed some of the challenges, high level challenges. The first is there is this misconception that people think that data governance is a IT owned project. It is not. First of all, it is not IT owned, and it's not a project. So I will get into the details when I talk about opportunities. So, and then there is other thing that there is lack of data ownership. So that is one of the biggest challenge I have seen, and there is lack of consistent data. A lot of consistent metadata. A lot of the metadata is up here. People they don't document it. It's um, it's not in one place. So people working in silos will definitely have different kinds of metadata to address. So that is one other challenge. The first and the foremost challenge, which I think is very important, is your senior leadership involvement. Because we are trying to implement a change here, we need the senior leadership to help us get through that change. So these are some of the major challenges that we come across when we get to start governing our data or start building the framework for data governance. So let's talk about some of the opportunities. So the first thing, let me clarify about the IT data governance not being an IT project. So data governance is not a project at all. It's not even a program. It's a process, because project has a beginning and an end, whereas the process, it continues until the good gets better and the better gets best. So that is how your data should be governed. And the best thing to go about implementing is to make your organization aware, and have them trained on all of how to protect their data, and how each one of them is a data steward. This starts from not just the data analysts or the people, the frontline people who work with the data, but also with the senior leadership, building a business case on getting some of these awareness out there. So a lot of communication needs to happen, all across the board for any data governance program to be successful. And the other thing which I have noticed, and we have implemented this in at EPRI, is the data stewardship. So we have built a very good data stewardship across all the different sectors. So we have different business units, different sectors. So as I had mentioned, that data doesn't belong to IT. It should be owned by the business, the subject matter expertise, and that is what is data stewardship all about. So we identify data stewards within within each of these business units to own their data. And then we also have legal stewards in our place who can help guide us around the sensitive data. And of course, we have IT stewards to help us navigate through any of the IT tools and support from their end. So that is some data stewardship that I would suggest that we establish in order to have a best data governance framework out there. And then the other thing is data catalog. Joanna, you have mentioned about the libraries and other stuff. So I was thinking about the data catalogs that we have out there. That is one of the other one of the major functions of a data governance is to have a data catalog established. So it is nothing but to get an account of all the data out there at your organization in and have the metadata defined for all of the data identified and tag that data. And tagging is something which is really helpful from an AI perspective when we get to writing any programs. The the first thing that a developer or an AI programmer goes out to is to look for the data. So 80% of their time is spent in searching for the data. So these data catalogs, the metadata that we make readily available, saves a lot of time. And then also they give a consistent definition of your data, and it also enhances the reusability of the data within the organization. So data catalog, metadata, um, a huge area of importance for data governance. The other thing is the data quality. Data quality is also something where AI can benefit, and also there are a lot of AI-based tools facilitate the data quality within an organization. So those are some of the high level opportunities that we can talk about. The data governance that we have to um, uh, work on in order to get the data governed and have the best practices for the data privacy. Jeremy, any questions for me?
Yeah, thank you, Seda. That was an excellent overview and discussion about some of the challenges and best practices that you've seen. We did have a number of questions come in via the chat from the audience. So the first one, I think this one would be to you, Saida. What are the best practices in data privacy when data is stored in the cloud?
Okay, that's a good question. Like a lot of people, they a lot of people think about the data being stored in a place which is not really their own. It is cloud is kind of someone else machines. Definitely, there are rules and regulations. Again, it's more from a cybersecurity perspective that we establish some checkpoints. And again, I would count on my data lineage, I am getting my data transferred from source to target. So how if I can keep tabs on where I am getting the data, what transformation it is going through, and what are the checkpoints and who has access to that. So from a data governance perspective, I think data lineage would be the way to go to establish what kind of controls that we have. But again, I think having the cloud and other stuff, it's more about the data cybersecurity and the more into cybersecurity area than the data governance, I guess. Any other questions?
Yeah, it looks like we have another question here. What efforts are underway to determine data provenance, establish policies to control and record data changes, including continuous monitoring?
Yeah, that's a very good question. So once we establish uh, the data governance, there are several ways. It's an evolving process. So we have to look at what are the inputs, what yeah, how is your data moving from one system to the other system, and the data lineage and all of this. Besides establishing the data lineage, there is a data monitoring that should go on in place, so that whatever you have established from a data governance perspective, it's intact. There is no tampering of the data. So what we did was, at EPRI, we had established not only the processes and policies for the data governance, the workflows, but also implemented change control process. So once we get the data governed and we have a monitoring going on, we have the change control process where anything which is governed, if it needs to go through a change, we have to implement a change control, trigger the change control, and the workflow that we have defined in here comes to place. So we have several roles defined. We have the data owners defined. We have, as I mentioned, the data stewards, the subject matter experts, and the legal stewards also defined for this one. So when we go through this workflow with the change control management, we get to the checkpoints in order for our any changes to be effective in this workflow, in the data flow.
Okay, yeah, thank you. And then the next question is, what are the data privacy norms for data gathering and transmission?
Okay, so the first and foremost thing is to establish the data classification. So suppose you have collected your data, you have registered all of your data, but how do you classify your data? Whether you classify in certain buckets, like, okay, this is the public data, this is data which should be internal to the organization, this is a confidential data, and then restricted data. Based on what kind of data you have defined, you will also have some kind of access controls around the data. You don't want restricted data to be kind of openly available for people. So you have different access levels defined to different kind of sensitivity of the data. So once you define the classification, you also work on the lineage. So you know what your data is going through, what source it is coming from, what transformation it is going through, what systems it is passing through, and who has access to what kind of data. So once we have this end-to-end data lineage, along with data classification and data lineage, would be the best way to go for implementing the data privacy for any data flow.
Okay, yeah, thank you, Saida. So I guess we have probably time for one or two more questions. I see one more question in the chat box. And the question is, does EPRI have any resources for implementing artificial intelligence for cybersecurity? So that's a great question. And yes, we do. We've actually been working on, for the last couple of years, a paper that really tries to identify the high priority use cases for implementing artificial intelligence for cybersecurity. And really what we focused on is we focused on the concept that I think both Wesley and Giovanna hit on, which is really focusing on bringing the physical security, or I'm sorry, the physical layer together with the cybersecurity layer. And we've actually seen these be utilized only separately. One is the operational information that a typical monitoring and diagnostic center sees. But we also see, an integrated security operations center or a SOC be implemented that's pulling all this security information, physical security information together. And so that's what we've done. We've focused on looking at different use cases, and we came up with about 10 to 15 high priority use cases, as well as a roadmap for implementation of those. So yeah, great question, and thank you. Looks like we have about 1 minute left. So with that, I'd like to conclude here. I just want to say thank you to everybody. Thank you to the audience for the great questions throughout this presentation. Thank you to our panelists, Giovanna, Wesley, and Saida. It was great, great getting your insight and talking through some of these different challenges and the potential for artificial intelligence to help both cybersecurity, but then also some of the challenges associated with data management and data governance. So thanks everybody. And I'll just say also we have our grand challenge session planned for Thursday. So looking forward to seeing everybody on Thursday morning. So with that, I'll turn it back over to Hannah.
Great, thank you so much, Jeremy. That was a great session. Lots of really good engagement from the audience, so you guys keep that up. We are going to take another 30-minute break, and we will be back at 1:30 Eastern for our last reverse pitch of the day. Don't think we're done at 2:30. We'll have one more session for breakout sessions at 3 o'clock today. So catch us back here at 1:30 Eastern time. Thank you so much, guys.